Welcome back, everyone. Today, we're diving into a really fascinating explainer covering the Titan BioGate Amtrak Cognitive Rail System, or ACRS for short. We're going to take what is honestly a pretty dense, highly technical architecture document and bring it to life. I want you to imagine a high-speed rail network that actually thinks, learns, and reacts in real time. That's exactly what we're unpacking today. Let's get into it. Okay, let's look at our roadmap for today. We'll be exploring this system almost like human anatomy. We'll cover the future of rail, Layer 1, the gateway, Layer 2, the brain, Layer 3, edge safety, and wrap up with the continuous feedback loop. All right, Part 1, the future of rail. Now, what's really interesting about this architecture is the massive shift it represents. For decades, rail networks basically relied on disconnected legacy systems, right? Siloed data, fixed tracks, manual schedules. But ACRS, it's a unified cloud-native intelligence platform. We aren't just talking about digitizing tickets here. We are talking about building a network that safely orchestrates itself. Notice the sheer flow of data from top to bottom. Up at Layer 1, that's where all the human interaction happens. That data then flows straight down into that central cognitive backbone, powered by Azure and OCI. From there, the resulting decisions get pushed all the way down to Layer 3, which is the edge safety operating directly on the physical trains and tracks. It's just a continuous, massive cascade of intelligence.
Moving on to Section 2, Layer 1, the gateway.
So, thinking about this like human anatomy, this top layer is essentially the digital front door. It's where the physical world shakes hands with the cloud. The multimodal API acts as the main communication hub here, using standard GraphQL and REST protocols to connect a massive variety of inputs. We're talking biometric entry through face and voice gates, along with your standard mobile ticketing and third-party apps. Plus, it feeds all this real-time data directly to executive dashboards. You can really think of this layer as the system's sensory input. It gathers and validates every single request from a passenger or an app before sending that data deep into the system's core.
Which brings us to Section 3, Layer 2, the brain.
All right, this is where it gets really cool. This is the AI orchestration center, the actual brain where all the heavy thinking, planning, and analyzing happens. Data enters from the top, flows through these 5 specialized modules from left to right, and exits at the bottom as actionable commands for the edge. As you can see, you have the digital twin engine, AI pricing, zero trust security, Kafka event streaming, and the hybrid cloud running the whole shebang. It's basically a seamless assembly line of data processing. Naturally, a brain like this requires some serious computing power. It runs on a best-in-class hybrid cloud, specifically Microsoft Azure and Oracle Cloud Infrastructure, or OCI. Azure handles the really complex AI services, the Kubernetes orchestration, and the digital twin simulations. Meanwhile, OCI steps in to handle the massive high-throughput data layer and elastic autoscaling. Working together, they deliver an absolutely incredible 99.99% platform availability, keeping latency practically non-existent. Let's break down that digital twin engine. It works in a really predictable 3-step rhythm. First, the input. It takes in live train positions and schedule data. Next, the process. It synchronizes that physical reality with a live 3D model of the entire Northeast corridor. This lets it safely run what-if simulations for routing before making any real-world changes. And finally, the output. Once optimized, it pushes those routing plans straight down to the physical tracks and surfaces the data to visual dashboards. Then we have AI pricing and scheduling. Here, the system constantly consumes historical ridership, live demand signals, and capacity data. It feeds all of that into advanced machine learning models to dynamically predict ridership by route and time. Ultimately, it outputs optimized fares and allocates train slots, sending that pricing out to booking APIs. The bottom line value here is absolutely massive, guys. It dynamically maximizes revenue while simultaneously optimizing on-time performance, a real game changer. Now, to connect all these thoughts, the brain relies on Kafka event streaming. Think of this as the internal nervous system. It ingests events from everywhere: pricing, digital twins, security, and track telemetry. It's processing and publishing over 10 million events daily, with sub-100 millisecond delivery. 10 million! It then outputs these streams to the data layer and pushes updates down to the edge. It does all this flawlessly, all while being protected by a strict zero-trust security model that constantly re-verifies and encrypts every single request.
Now that the brain has made a decision, it sends signals down the nervous system to the edge. Section 4, Layer 3, Edge Safety.
This is where the brain's decisions turn into the physical muscle and reflexes of the train. Across these onboard and trackside modules, the system is built to incredibly strict FRA Part 236 and ERTMS Level 2 and 3 standards, meaning it is entirely fail-safe. If a train ever loses connection to the cloud, or if it detects literally any fault, this edge layer defaults immediately to a restrictive stop, because, safety never waits for an internet connection. And this brilliantly illustrates a massive leap in technology: the shift from legacy fixed blocks to moving block signaling. In the past, trains were separated by static, physical track sections, which obviously severely limited how many trains could safely run at once. But ACRS, it uses dynamic train-length safety zones that actually travel with the train itself. By communicating live positions, trains can safely run much closer together. This instantly drives a vast increase in corridor capacity without laying down a single new piece of track. Let's look at how this works on board the train. The real-time control system continuously reads inputs like current speeds, speed limits, and calculated braking curves. Then it runs its own automatic train protection, completely independent of the broader network. Finally, it feeds its state to those moving blocks and issues automatic brakes if any violations occur. So even if the train is deep in a tunnel without any cloud connection, these reflexes are guaranteed to always be active. Just to make sure we all understand the severe safety stakes here, we need to talk about a SPAD, a signal passed at danger. This is basically the absolute worst case scenario. It happens when a train passes a signal indicating it must stop, creating a severe collision risk. Preventing a SPAD is exactly what edge safety is designed to do. To completely prevent a SPAD, the Positive Train Control Enforcement, or PTC, steps in. It continuously monitors speed, movement limits, and IoT safety alerts, like, say, an obstacle on the track. If it detects a SPAD risk or any speed non-compliance, it automatically outputs a command to apply penalty brakes. This is an FRA-mandated safety net, but will literally override a human operator to guarantee passenger safety. Which brings us to our final crucial component, Section 5. The continuous feedback loop. For a system to be truly cognitive, it actually has to learn over time. Layer 2 plans, Layer 3 executes, and the telemetry loop connects them. If you remember that dashed feedback loop from the system overview, this is it in action. IoT sensor wear patterns, GNSS satellite positioning, weather data, and safety events are constantly streaming back up to the cloud. This real-world telemetry is used to continuously retrain the AI models and the digital twin, so the entire network literally gets smarter every single day. So, the crucial point here is the measurable bottom-line impact. By utilizing moving block signaling and AI scheduling, this system delivers an incredible 20 to 30% gain in overall corridor capacity. Think about that. You're running significantly more trains on the exact same physical tracks. But, of course, capacity means absolutely nothing without safety. Through the onboard PTC enforcement and real-time control, the system targets exactly 0 signals passed at danger. 0. And it achieves all of this while maintaining a staggering 99.99% platform uptime, processing over 10 million events a day with under 100 milliseconds of latency. It's fast, it's resilient, and it's incredibly secure. I'll leave you with this provocative thought. If a cloud-native intelligence platform can flawlessly coordinate a high-speed physical rail network today, what infrastructure will this transform tomorrow? ACRS isn't just a ticketing or scheduling system. It's a living blueprint for safe, automated infrastructure across the globe. Thank you so much for engaging with this explainer. We really hope you walk away with a crystal clear understanding of this incredible technology. See you next time.